This lesson is on adding and subtracting radicals. When you add and subtract radicals, just as you do with values that have variables, you need to have like terms. So just as I might have something like 6x plus 4x, I can add together because they both have the same x, that would be 10x. If I had 6x squared plus 4x, those are not the same and I couldn't combine them together. The same holds true for radicals. We're looking for like radicals. So they need the same radicand, which is the stuff on the inside, and they need the same index. So here, 5 square root or fifth root of 2 plus 4 fifth root of 2 gives me 9 fifth root of 2. So it's kind of just like our x, where it's the same label each time. This one, however, notice I've got the fifth root of 7 and the fifth root of 6. I can't combine those, and so that would be my answer. I couldn't do anything with those two things. My last one, I have xyz squared, xyz squared, xyz squared, and they're all the square root. So I can combine 3 and 10 to get 13, minus 5 to get 8. And so that gives me 8, and then square root of xyz squared. However, the squared and the square root, I can simplify that a little bit further, and so this z squared, 2 divided by 2 is 1, so I have 8z, and the x and y stay on the inside. Try these questions on your own, then press play to see how you did. For the first, I do have the same radicand and the same index, so I can take 6 minus 2 to get 4, radical 11. For my next, I have radical, or the fourth root of 5 plus the fourth root of 5. Remember, there's an imaginary 1 in front of that, so it's one of those, and another one of those gives me 2 of those. 2 times the fourth root of 5. And the last one, I have the third root of AB, third root of AB, third root of AB. So it's negative 2 plus 7, which is 5, minus 1, which is 4, and then the cubed root of AB. Sometimes we are asked to add or subtract radicals that are not already the same, and sometimes we are actually able to turn them into like radicals. So for instance, in my first question, I would write 256. I would go ahead and make my little factor tree for 256 to break that down. 256 is 16 times 16. Each 16 is 4 times 4. And each 4 is 2 times 2. So I could rewrite 256 as 2 to the 8th. So the cubed root of 2 to the 8th. And 32 is 2 to the 5th. And so I'm going to rewrite this and hope that when I'm done, I end up with the same radicand with the same index. So 8 divided by 3 is 2. And I have 2 left over. 5 divided by 3 is 1, so I already had this 4 out here, so I have now take it times another 2, with 2 left over. And now let's get rid of all these 2 squareds and 2 to the third, whatever. We have to simplify. So this is 4, cubed root of 4. 4 times 2 is 8. And this is the cubed root of 4. And now look what happened. I've got the cubed root of 4 and the cubed root of 4, and now I've got 2 values that I can combine. So 4 minus 8 is negative 4, cubed root of 4. So we did that by simplifying the radicals that we had. For my next one, I have a 3x on the outside. I have the cubed root of x to the 4th y. So to simplify this 4 and this 3 obviously can reduce. I can bring another x out. So I have an x out here. I'm bringing another one out, which makes it 2 x's on the outside. On the inside, I have the cubed root of xy. So one of the x's stayed in, the y obviously stayed in. For my other term, 3 divided by 3 gives me an x on the outside. 5 divided by 3 gives me a y on the outside with 2 y's left on the inside. Notice this is the cube root of xy, this is the cube root of y squared. Those are not like terms, so I can't combine them. So that's all I can do on that one. I can't add or subtract. Here are 3 questions for you to try on your own. So try all 3, then press play to check your work. For the first, again, I'm going to do some simplification first because they're not like. So I would take 3 divided by 2, which gives me x to the first on the outside, with, of course, 1 left over. Whoops. And then 2 divided by 2 is 1, so 1 on the outside. Same thing's going to happen here. 3 divided by 2 is 1. But there was 1 left over. And now I've got 8xy minus 3xy, which would give me 5xy square root of x. So because they were like here, I could combine them, and because they were like here, I could combine them. So 5xy radical x would be my lowest form answer. My next one, again, I've got a hot mess of stuff here that can't be combined quite yet. Hopefully when I get to the end, I can. So I have 50, which is, of course, 25 times 2. So I would rewrite this as 5, and then 2 divided by 2 is 1, and 5 divided by 2 is 2, with 1 left over. So I've got a 2 and a y left on the inside. This one, the 13 would stay on the outside. I would have an x because 2 divided by 2 is 1. I would add a y out there. I've already got 1, but 3 divided by 2 says I should have another one, so that's y squared. On the inside, I still have this 2 and that y that's left over. And the last one, 98, is 49, or 7 squared times 2. So the 7 is going to come out. There's an x out here. There's 3 y's on the inside, so 3 divided by 2 is 1, which I'll combine with this 1 here, so that's y squared. A y left over and a 2 left over gives me the square root of 2y. And now I've got square root of 2y, square root of 2y, square root of 2y. We can combine 5xy squared minus 13xy squared plus 7. So I'm going to combine all of those to get negative 1xy squared square root of 2y. You don't even have to have the 1, you could just have a negative up front. And then my last one, this turns into 3y square root of 2 plus 8 is 2 to the third. So a 2 could come to the outside, and inside I would have 2 and y. So notice, even though they both have y's and they're both square roots and they both have a 2, I can't combine them because there's no y left over here. So that's my final answer.